welcome to this model Relations in Set Theory. This is Ms.R.Soundaria, Assistant Professor, Department of Mathematics, Kaveri College for Women, Trichy. Now let us consider relation. Let A and B be two non-empty sets, then every subset of A cross B defines a relation from A to B, and every relation from A to B is a subset of A cross B. This is a diagrammatic representation of set. Next, let us consider relation. So, relation is nothing but empty, universal, identity, inverse, reflexive, symmetric as well as transitive. Next, let us see empty relation. So, empty relation is one in which there is no relation between any elements of a set. Next, let us consider universal relation. It is a type of relation in which every element of a set is related to each other. Next, let us consider identity relation. Identity relation, every element of a set is related to itself only. Next, let us consider inverse relation. This is the relation a set has elements which are inverse pairs of another set. This is a diagrammatic representation of inverse relation. Next, let us consider reflexive relation. In a reflexive relation, every element maps to itself. For example, A equal to 1, 2, etc. 8. So, A comma A belongs to R. This is the example. X greater than Y means it shows like that. Next, let us consider symmetric relation. In a symmetric relation, A equal to B, which implies B equal to A. Then let us consider transitive relation. A relation B and B related to C, which implies A is related to C. For all A, B, C belongs to A. Let us see the example of equivalence relation. A relation R is defined on the set Z such that A minus B is divisible by 5. Examine if R is an equivalence relation on Z. The first condition we can check it easily. A minus A is divisible by 5. So, it's like R is reflexive. Next, A minus B is divisible by 5 and B minus A is also divisible by 5. Therefore, R is symmetric. Next, A minus B and B minus A are both divisible by 5. So, it's like R is transitive. So, it satisfies reflexive, symmetric, transitive condition. Therefore, R is an equivalence relation. Next, let us consider the representation of types of relations. The relation type is like empty relation, universal, identity, inverse, reflexive, symmetric, transitive. And let us consider partition. A partition of a set is a grouping of its elements into non-empty subsets in such a way that every element is included in exactly one subset. Now let us consider equivalence relation. For any equivalence relation on a set X, the set its equivalence classes is a partition of X. Next, let us consider the partial order relation. It is a relation, partial order relation, if it satisfies the following three properties. It's like a reflexive, antisymmetric as well as transitive. Now let us consider n-RA relation. It's like a n order tuples, and the product set S to the power is called the n-RA relation. This is the subset of S cube is called the ternary relation on S. Thank you for watching.